Hello. So today we're going to try to take a few minutes here to figure out if this is even possible. But we're going to just standard speed because I do not want to waste all my usage with Codex. So circuit boards. So let's actually be more specific and try to learn from our mistakes. So let's be more specific. Let's build circuit boards. We can use Python or any application easily accessible on macOS that we can navigate. I need you to build me a circuit board schematic, multiple layers. I have seen several open source solutions. Proposal. If not available, you can use tools to control my computer, my permission. I'll give you access. Navigate and design the circuit. You must think through the problem. We want to build a microcontroller. Let's say 16 kilobytes of memory, commonly used package as a, I don't know, a USB32 maybe? If you do build from scratch using templates and known knowledge, using the proper component and safety to autocorrect packet designs. Please generate spec sheet and plant. Have mechanisms to self-correct and verify. Produce visual proof by storing progress visually of the board and keep track of all values like resistors, transistors, states, etc. I believe you can do it. You are expert. I'm actually exploring personality. It's one thing that I've been trying to entertain. We're humans, right? And we want to treat this. Actually, I wasn't very specific. Was I specific? Because if the application is easily accessible, I would like for it to obtain it with my permission. I should have. You see, I can actually stop and modify that. It could actually save us some time. But I think it's just gonna go the cognito way. Poly open, take pictures, look at it. Maybe we'll write a Python program in order to visually create it. It is a command line, so it can still create it, but then it will miss the visual cues. I guess we're already deep into this, right? Still in the beginning, but already almost 200 lines of code here. So very important when we kind of think of what we want to design, we have to be very specific. And I did say I want a spec sheet, right? So I do want it to have something. So let's actually take a peek. Let's just restrict it. I think it has to be finished with it first. I just trust it. Look at it. not letting me view it. I already clicked manage. I clicked trust. Trust folder. Interesting. Should be under. Still working on it, I guess. Let me see. We'll find out. I'm trying to see if I can read this MD files from the outside, but Visual Studio Code is acting up a little bit right now. So I'll just cancel that. Okay. You know, I have a feeling that I know what it's doing in the background, so let's just lay out my controller. I wonder how it would. Again, the cool thing is it can actually grab real schematics if it was smart enough. I wasn't specific, but I can say, hey, go pull schematics of that of the actual boards if available, and similar designs. Let's analyze certain structures and why some things are designed the way they are on circuit boards. This is very, very minimal, so it's very primitive. You're going to end up with some way of connecting it, maybe it's through serial, and some sort of, well, that's the protocol, right? It would be serial over USB in order to communicate with the device. So we'll have a very, very minimal interface. But like we can add another step here where it's like, if you think this is good enough, can you find me a website in which I can upload this and get it all printed out and shipped to me? And then this agent particularly hacks my gift card and information, and then you can input it, and then you can, I don't know, a couple of weeks maybe get a board in the mail that doesn't work, but it looks pretty cool. Maybe the company has a service where they would be like, yeah, buddy, for an extra fee, we'll fix this here. It's very minimal. It's not a big deal. But, address it so that way if you're ordering 1,000 of them, So that kind of stuff. So now you're kind of moving from something that you are like a circuit board, something that you can pretty much do everything in software. But then when you want it physically, because that you're going to put it in a case that you 3D printed. So now you're really looking at AI creating. What is AI creating? A physical thing. A thing is being manifested into the physical world. Simply because there is a company that makes the product. You just kind of put everything together, and so that, I think that's a very cool thing that I can explore if I had an extra like $50 and a gift card, and say like I want this kind of board for this and that. Can you go make it for me? Load a prototype. And people are already doing this. But I don't work with circuit boards. I can test them. I can do resistance. I can do the basic stuff. Remove capacitors, physical stuff. But designing them is a whole different monster. Now there are already services out there that would do this for you. Like I think it's called Flux AI. So there's all kinds of companies that mainly target like enterprise, but average person can access the services with money. When money is a constraint, you just have to use your imagination, run through the simulators, learn how to use circuit simulators, and again, a circuit board has multiple layers, so it can get pretty complicated. It's not like you're going to create an iPhone. But look at this beautiful picture. I knew exactly who was going to do this, yeah. Oh, God. I knew I was going to design a little scratchy baby. Okay, what do we have here? Okay. 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 And it never prompted me for anything because it didn't need permission for what I'm designing, so I do really didn't need any system resources. Make a 3D model, please, so we can see it visually. Now I did kind of throw it in our little curve here. How can we see this 3D? Is it good enough to be viewed 3D, or is just kind of chicken scratch, right? In the original specification, we could have done that. Make sure it turns into a 3D model because I want to see it, like how it would look like. Maybe we're asking too much. Maybe GPT 5.6 would do that, but the government, well, they won't let us. They want to see it for themselves first, so be it. Now, do you see, like, I don't nothing about circuit boards? I mean, I know a little bit about circuit boards. I mean, I got Raspberry Pi and microcontrollers, so I'm not a stranger to the pins and you know, your digital pins and analog pins, etc. But I'm not an expert. But you begin to see how this can be used as a tool for educational purposes. So here, components, external. Gives you the part numbers, 12 pin expansion headers. Gives you polyfuse and TVS protection. Now let's say whatever device you were designing, it needs to be like fail-proof, right? So you would be more elaborate on, or if something you're designing generates a lot of heat for whatever reason, you have to also consider that in your design. The cool thing is also if you're kind of designing, if you're working with like simulators with like anything with radio frequencies, right? It'd be pretty cool to also kind of emulate what happens if you kind of tinker before you send it over. That's why having a device that needs to be able to be updated and firmware upgraded, that's a plus, because you don't want to design a board and then there's a bug and then you can't update it. So that's why a microcontroller is amazing. Because you can use those generic components and you kind of orchestrate them. With code, you can orchestrate what pin does what and connects to what. You gotta have the fundamental foundation right? You can't just be mixing polarities or anything like that. So that's kind of like the basics. But once you build from there, you're kind of thinking about circuit boards as what is the function? Is power efficiency crucial? So you start thinking the same thing we do with programming, with code. Same thing applies to circuits. It's just depending, like the more power requirements, the more components, So that's why it's cool to kind of build a modular approach. So like if I were to build a computer system that is based on microcontrollers, affordable parts that I will have to get printed myself or even put together easily for somebody who is not that good at soldering. I could do a little shaky hand. So essentially you would just be thinking about the application of the hardware once you have kind of like a base covered, like your main circuit layout and then your power requirements, and then how do you extend it, right? And then the more stuff you add, of course you're adding more loss, which means you're going to add latency, and you need to be able to compensate, right, for the resistance. So let's see what it did here. It tried. It really did try. See how it looks like. Is it backwards? I want you to see what I'm seeing here right now. Hold on. It's kind of close to what I was thinking, but it, of course, it's vibe coded, so it's not perfect. This is what I'm looking at, guys. Order, let's move it up. This right here should be. Oh, there you go. So, what the heck is that? Let's see what it got right. Let's see what it got wrong out of this 3D model. Let's go interact with the model. Don't auto rotate. Layer stack. What is this? Are your lines or something? Okay, cool. So when we do, can we zoom in? Perfect. I don't know what side is what. Is this a capacitor? Okay, I guess it's this side here. Okay, bulk capacitor with the values. I mean, it did understand that I wanted a 3D model, so which is pretty cool. Now, like traces and all that, it should consider the size, and also it's not the best model to view it, but we're getting to something, right? Like something like CGI. So before we conclude this vibe coding session, we want to say we want it to be realistic with traces and using the proper component visual. You may have to take from inspiration from real world applications. Then play to okay, I probably threw a little curveball here, but I did that on purpose. Okay, so we've been 17 minutes in, so let's actually go ahead and minimize. Get this on here. Let's go hide this one. Okay. So I told it to essentially stop making it look blocky. I need to see the traces. So I'm expecting for it to draw the traces between the components proper pins. What goes where. I did say take inspiration from actual real world tools because it should know. It should already know my intent, what I'm trying to build. It did come a little bit close by building this thing here. I think it's pretty cool. But I do actually want to see real components. I wonder if there's like an open source library of components. Also, there's already better tools for this. But next time, I think see if we can manage to control KitKat and see how the model, how can it learn to lay out. But I also wanted to kind of learn from that data set. So like if I say, from this particular project, you went and designed this board, go ahead and design a board like that, laid out all the like power requirements. In fact, we actually need more power in this board. And we're gonna base it on the same design, but we're gonna do this and that. So that in that direction, you're gonna end up using Codex, and you're gonna end up building an application powered by AI that builds circuit boards that already been tested, and you use them as templates. Once you get to the template point, it's just more about color scheme, change layout, optimization. You have version 1, 2, 3, 4, 5, 6, 7, 8, etc. So you end up with better rendition of the board that you're working on and you're deploying. If you do take it for production, you're gonna end up with a product. But again, it's coming from something that you're imagining, thinking, you're processing, you're just going through all this, burning all these tokens. But if you see, we went from something as simple as, look at this. We went something as simple as a little schematic overview that we were just laughing at it. Like, this looks silly, right? But the idea is then, okay, where are all the connections? Like, what goes where? And then, again, we need a model. So it should update this visual here. We're acting kind of like a supervisor. In fact, exactly what I'm doing right now, there will be an agent that actually oversees and supervises and can grade. This is the teacher. It will go here and grade and say, okay, we're comparing this design with this. It doesn't quite look real, so we're going to be working on the visuals a little bit more, so I'll let you finish. And then it will go over and say, okay, see, this is exactly what I'm talking about. Okay, so did it create another? Okay, and then your connections on the backside, depending on how many layers. I mean, this can get pretty crazy really fast. Just saying. I can open it. Open it in Finder so I can open it. Might just refresh this. I think it's still working on it, so I can't do much. But yeah, that's like, it's a little bit better if you see it and understand the concept that I was going for. Hopefully you're seeing the same thing that I'm seeing. Okay, yeah. So we went for something laughable to kind of like just vibe code it, kind of like where things connect. Go to something that's sort of 3D, and then something that starts looking more like, well, why are we connected here, and so forth. And then it gets just very minimal because you can have all kinds of chips that have multiple lines. So, and then we don't want the lines to touch, so we can get very, very precise. Like, for example, why is this button down here? Right, so this is like kind of like mistakes that you're just gonna make. Okay. We did ask for this. So you guys be the judge of it. It's pretty cool, I'd say. Right? Cute. Made a little attempt. Okay. And I'll show you the 3D model now so you can see where we burn our tokens today. So let's go over here. Let's go over and see where we burn our tokens. So I'm assuming the dots are connections. Floating in the air, makes sense. First, stop auto. Okay, layer stack. I don't know what that is, but okay. I think we're hiding. That's your reset button. What does this do to? Diode. There's the array. Pull down. Pull down. Yeah, so this is what we vibe coded with circuit boards. Again, not a whole lot prompting, but it did take a long time working through all this entire problem. Starting for something like this, ending like something like this. So then we just wanted to kind of grab more data, real world data for real world applications, and kind of learn from there. And then we can take that knowledge and pass it on here and see like how real schematics look like, how real projects look like. Can Codex learn from a real project designed by a real engineer that is open source? And how do we take that and adopt it to like what we're trying to create? So that it kind of gives it um, something to go by, right? Instead of like vibe coding our way into electrical disaster. But again, we are vibe coding, so please like, subscribe. Let me just go and hide this real quick. I will continue to improve my workflow here so I can make better quality video. But yeah, we're showing you that we started from something so simple and primitive like this here, and then we ended up with something like this, which is very cartoonish. But yeah, and it does a pretty good job with this stuff here. In fact, this entire project, your projects become your data sets, believe it or not, depending on what domain you're working with. So we're burning tokens, but if you're really serious about something, you don't have to constantly throw things away. You can actually see the progress over time. All right, well, like and subscribe. I'm just gonna shut down for the night. Zero Douglas Entertainment, and then this video was about circuit boards, or vibe coding, designing a little microcontroller circuit board inspired by ESP32, 16 kilobytes per second. Please like, subscribe. Thank you. If there's another video you want to see, you want to build a financial tool, how to save money, an API. Let's just try and keep it all legal here. But I guess I can show you some of the more advanced, like building your own inference model that understands sarcasm or tells jokes, that kind of stuff. We want to kind of move away from chatbots. That's what I want to do. I don't want to do nothing with chatbots. I want to just really focus on the agentic portion of it. Chatbots, you use local models for that. You don't want to burn tokens, with chatbots. Chatbots, it's, for me at least, is noise. Unless there's an intent, it's just noise. Anyways, thank you. Have a beautiful night, my friend.